Here at the San Francisco Bay Naval Shipyard, workers prepare Sealab 3, a special habitat for ocean floor dwelling, to be used by the aquanauts of the Navy's most ambitious undersea experiment to date. Already used in Sealab 2, major modifications to the cylindrical habitat were the addition of 2 rooms to the ends of the central section and an anchor ballast tank which would allow the habitat to remain level on the sloping ocean floor. Once all systems had been successfully tested in the dry environment, a dry dock is flooded for the evaluation of submerged tests of safety, reliability, and performance needed for the life support of the men who would live and work in and out of Sealab during the deep ocean experiment in the Pacific. Primary objective of the Sealab 3 program is to evaluate techniques and equipment being developed and to extend man's capabilities to the limits of the continental shelf. The prototype of such a deep diving system was built into the support ship Elk River. A vital part of this system is the PTC, or Personnel Transfer Capsule, a pressurized elevator needed to transport divers to and from the ocean floor. Dress rehearsal site for the evaluation of special tools and equipment used by the salvage and construction teams in their parts of the ocean floor program is held near Anacapa Island, California. Like a couple of ocean astronauts, the divers don special headgear that provides protection, two-way communications, and a breathing system for life support. At 600 feet, his breathing gas of helium and oxygen, in correct mixture, is supplied by an umbilical from the habitat. Fully dressed, the aquanaut must carry 140 pounds of equipment.
Man, get ready to go in now.
In this experiment, aquanauts use a zipper to adjust the amount of lift desired in a variable buoyancy lift system. Since salvage work demands heavy heaving and hauling, this portable crane can lessen their burden. A diver tool test stand serves as a workbench where the performance of tools is actually tested. One of these is an explosive stud driver, using gunpowder as a source of energy to drive studs through 1-inch armor plate. A human factors expert notes the time needed to complete each task, comparing their reactions to other environments like outer space. At the same time, members of the construction team were about to practice their part in the ocean floor program to build a 15-foot tall house on the sea bottom. Using special lift devices and equipment, they will assemble 3 large concentric iron rings into a dry storage and repair facility. Techniques learned in this experiment can lead to construction of other, larger structures and will eventually be the forerunner of major industrial and research complexes on the continental shelves of the world. During its brief stay at the shipyard, the underwater capsule is loaded with all the special equipment needed to make a habitat a home. Once positioned in a 5-point moor, the Elk River begins final testing of the deep diving system installed during its conversion. A large gantry crane lifts the pressurized elevator and moves it forward for lowering through the center well. Use of these capsules allows quick, safe transfer of aquanauts to and from the ocean floor. Helium and oxygen flasks, mounted on the outside, contain the proper mixture of gases the diver breathes during transit and while making excursions from the PTC. The salvage ship, USNS Gear, tows the fully loaded habitat on the last leg of its journey from the shipyard at Long Beach. Arriving at the experiment site, it awaits offloading by the large floating crane, the Marine Boss. Now the large crane must lift more than 300 tons of ocean floor dwelling. The Sealab, resembling a railroad tank car, is almost 70 feet long and is painted a bright yellow for underwater visibility. With down day approaching, aquanauts and support personnel complete final inspection of all deep diving system components.
Monitor control, this is capsule 2 for communications check.
Over. Below him, similar tests are being made between the deck decompression chamber and the main control console, which is the nerve center for the exacting process of careful decompression needed to bring men back to surface pressure from their saturated dive. Divers enter the water while Sealab is held at 25 feet for a final visual check before the lowering continues. Pressure of the gas within the habitat is kept slightly greater than that of the surrounding ocean to prevent flooding. During the night, a remote-controlled camera system monitored the habitat, while closed-circuit television cameras provided a close watch on the pressure balance within Sealab. Early the next morning, pressure begins to drop. Gas is somehow leaking from the habitat. The leaks in the habitat are visible to the aquanauts as they approach the ocean floor. Gas is escaping through penetration fittings in Sealab's hull, and more gas must be pumped down from the surface to keep the habitat from flooding. The on-scene commander is faced with a real dilemma. How is he to get the habitat back to the surface? It is still leaking badly and has the added weight of 17 tons of seawater in ballast tank number 3. Aboard the YSD-60, engineers prepared to make modifications to the counterweight system in order to handle the additional 17 tons of weight. To do this, 20,000 pounds of additional weight is added to the counterweight, bringing its total to about 35,000 pounds. And the weaker points in the raising system are either bypassed or strengthened by on-the-spot bracing to prevent buckling. When the habitat was at 100 feet, divers entered the water to blow the ballast from number 3 tank and to attach nylon lines to guide Sealab into a clear area for surfacing. Crews took up slack on the guidelines while support divers manned small boats. Then, suddenly, gurgling and gushing, the habitat surged to the surface, safe after engineers gave her a 1,000 to 1 chance of ever getting off the bottom.
Recovery of the habitat under emergency conditions was a truly outstanding performance. It will in due time enable us to complete all of the goals of Sealab 3 program.